4.4 scatter plots and line of fits. So a scatter plot is a graph that shows the relationship between two data sets. The two data sets are graphed as ordered pairs in coordinate plane. Scatter plots can show trends in the data. A scatter plot allows you to see the trends, correct? You can read a scatter from left to right. As x increases, the y will be increasing or decreasing, or it by staying the same, or there will be no pattern. So remember always that in a coordinate plane, our ordered pairs are always going to be x and y. It's very important to remember that, x and y. Here what we're going to do is in example 1, interpret a scatter plot. The scatter plot shows the amount of x, which are grams, of sugar and the numbers of y, of calories, and 10 smoothie. So we know that we are comparing how many? 10 smoothies to the amount of the grams what's happening. So in A, question A tells us how many calories are in the smoothie that contains 56 grams. So we know that sugar is X of down here and the calories is Y. So if I look for 56 grams, first we need to identify. Always remember that this breakage that you see right here in a graph means that you're starting at 0 in the origin always, but there's a big gap between numbers. It's going to jump numbers. In this case, we're jumping by, we have 46, 50, 54, 58, 62, 66, and 70. We are jumping by 4. And vice versa and Y's. We are climbing by 10, correct? 240, 250, 260, and so on. So if we're looking for 56 sugars, we need to identify that sugars is down here. 56 grams. 56 grams is going to be in between 54 and 58, right in the middle, correct? So if we look here, right in the middle, we have what? We have our dot right there in the middle. And that corresponds to how many calories? To 260. So, not 260, I'm sorry, 270 calories. So the smoothie in A, the smoothie has 270 calories. In B, we have how many grams of sugar are in the smoothie that contains 320. So now we're doing the opposite effect, correct? So we're going to look for 320, correct? 320 is up here. So I'm going to look at to what point I finally see a point that meets. And it meets right over here. Going down tells me I am at 70 grams of sugar. The smoothie has 70 grams of sugar. And C, the question they're asking us is what tends to happen to a number of calories as the number of grams of sugar increases. We can see that the number of grams of sugar increases, correct? It's going up, increases the number of calories are also what? Increasing. We're now going to identify correlations between data sets. Basically, correlation is the relationship between the data sets. You can use a scatter plot to describe the correlation between the data. So if you see in the positive correlation here, you can think of your slopes. You have the positive, the negative, then you have your horizontal and your vertical, correct? Which is 0 and undefined. If you notice here, you can see that the trend is going increasing, correct? On the first example. So you could say as X increases, what's happening with Y? It's also increasing because it is positive. When it's negative, X will increase, but Y will decrease. And finally, no correlation. You see all your points show no pattern. They're all over the place, okay? So it's going to be no patterns. Very important to look at the patterns. Example 2, identifying the correlations. Tell whether the data show a positive, negative, or no correlation. A, age in vehicles owned. So that means a person's age being compared to the number of vehicles owned. We kind of could tell that there's not going to be no correlation. The age of a person does not determine how many vehicles the person has by a certain age, right? Is at a certain age. So in A, there is no correlation. The scatter plot shows no correlation. What about in B? Temperature and cost sells at stores. We could see that the higher the what? The temperature, what's going to happen with the coats? It decreases, correct? So the lower the temperature are, the more demand for coats there is. When the higher the temperature are in Fahrenheit, the less the demand is. So this is giving us what? A negative correlation. Basically, what's happening? X is increasing, but Y is decrease. Using lines of fits to model data. Important thing is a line of fit is a line drawn on a scatter plot that is close to most of the data points. You're going to have to follow certain steps to determine the line of fit. First, you always have to make a scatter plot. 2, decide whether it could be modeled by a line. 3, this is very important. If you move on, obviously, if it's a no correlation, we stop. It either has to be a negative or positive, correct? In step 3, we continue. You need to draw a line that appears fit the data closely. There should be approximately. Approximately means almost. It doesn't mean it exactly. As many points above as below the line, okay? And in step 4, we're going to write an equation using 2 points on the line. Make sure that when you see the line of fit, the points have to go through those lines, and that is the 2 points that you're going to use because they do represent the data actual pairs. But they must lie on the line of fit. Meaning that sometimes, as long as it passes through, but they might not have been given to you in a table. Example 4 is telling us finding a line of fit. The table shows the weekly sale of a DVD and the number of weeks since its release. Write in equations that models the DVD sales as a function of the number of weeks since its release. Interpret the slope and y-intercept of the line. So I already know the slope and y-intercept. I'm going to use my slope-intercept form, which is y equals mx plus b. That is the line that we're trying to look. We know that weeks is x and y is my cells. So down here we're going to have weeks and here we're going to have cells. Weeks are how many weeks? 8. So we're going to have 1, 2, 3, 4, 5, 6, 7, and 8. My cells in millions ranges from, can we tell already that it's going to be a negative slope? Yes, because what's happening to my x's? My x's are increasing, but my y's are decreasing. So that means it's going to be a negative correlation. We have 19 to 5. So what I'm going to climb is, I'm going to do them by 2. Remember, we start at 0. So I'm going to intervals of 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. If you up for it, you can always do 1 through 20. But it's easier when you condense them, okay? So our first order pair is 1n 19, which is going to be somewhere here in the middle. 2n, 15, 3n, 13, 4n, 11, 5n, 10, 6n, 8, 7 and 7, and 8n, 5. So that is step, right? That is step 1, create a scatter plot. Step 2 is do a line of fit. I'm going to do a line that is closest resembles what? Through the line of the scatter plot. So I'm going to do a line through here. And do I pass through any 2 points? Very closely, I pass through these 2, correct? What order pairs those are? 5 and 6, correct? So because they pass through the line of fit, I'm going to use those 2 points to help find my equation. So we're going to have 5 and 10 and 6 and 8, correct? 5 and 10. I don't know why I wrote 5 and 0. Okay, so let's find first a slope. We're going to have 8 minus 10 and 6 minus 5. 8 minus 10 gives me -2, and 6 minus 5 gives me 1. Therefore, my slope is -2. Can I do the same thing how we did in 4.3 that we found our y-intercept by plugging in? We've given 1 point. I'm going to use which points? I'm going to use 5 and 10. Okay, you could use any as long as it passed through the line, okay? In this case, it passed through that, 5 and 10. So I'm going to have, remember, I'm going to have y equals mx plus b. What is y? This is x and y. I'm going to have 10 equals, my slope is what? -2 times 5 plus b. Now I'm able to solve for b, which gives me 10 equals -2 times 5 gives me -10 plus b. I'm going to move over my plus 10 to solve for b. So b equals 20. So I already know that my equation is going to be y equals -2x plus 20. What can I understand with that? I'm having a negative what? A negative coordination.